Howdy, howdy, howdy. You're back again, and that's awesome. Thank you for tuning in. Let's get right to this. Still working in Unit 7. We are on to Lesson 7, still working on factoring polynomials. Reminder that I told you last time, there are so many different kinds of polynomials, and they all look different. And so when we go to factor them into their smaller components, it's not just a one-size-fits-all approach, right? There are all these different ways that I have to show you how to factor a polynomial because there are so many different kinds of polynomials. So now we're going to move on to this thing called a trinomial. Specifically, trinomials that are in this format, where you're going to have x squared, then you're going to have a plus bx, and then you're going to have that could be a minus, by the way. I hate that it says plus, because it really could be plus or minus. Okay, and then you're going to have another term out here called the c term, and that's also, it says plus c, but it really could be plus or minus. So let me show you how I would write this if I were writing the rules of math. I would write it like this. It's a 1 x squared plus or minus the bx term plus or minus the c term, because in reality, that's what you're dealing with. What's called the leading coefficient here on your x squared for today is always going to be a 1, and you're welcome, because these are the easy ones. In the future, we're going to do some trinomials where this is not a 1. It could be a number like a 2 or 3 or a 5, and that definitely is going to complicate the factoring process. So we're starting with the easy ones where your coefficient is a 1 here, okay? But then again, plus or minus this term, and then plus or minus this number out here. I want to remind you about the checklist, the questions, the 5 questions that you need to be asking yourself as we're factoring quadratics as we approach each one. First question, can you factor anything out? If you can, you should. We haven't done grouping yet, so don't worry about the grouping yet. Difference of squares, right? That's a fair question now because you've learned difference of squares. So I can throw a difference of squares at you anytime, and you need to be able to spot it. If not, maybe you have what's called a perfect square trinomial. We haven't done those yet. And if not, you all the way down here to what's called the long way. What I'm going to teach you today is the long way. So we're kind of here, there, and everywhere, right? We've done this one, and now I'm teaching you this one. You're probably thinking, why are you teaching me these out of order? Because I am, okay? Because I am. So the factoring today, I'm going to call the long way, and you're going to see why it's called that. The long way. Factoring polynomials, trinomials, the long way. Okay, here we go. Let's see. Let's start with the little hint they give us. It says, to factor a trinomial of the form above, that, remember there's a 1 there, that could be a minus, that could be a minus, you must find 2 integers, positive or negative numbers, that multiply to get c. So you're looking for 2 numbers that multiply to get c, and those same 2 numbers have to add up to b. So they have to multiply to get this, and they have to add to get that. Right? So understanding factors of numbers and understanding fact families, super important here. All right, I'm going to go straight to my notebook paper because this is just so tiny. So tiny. Okay. Let's start with number 1. Come on, focus. I feel like this thing has a mind of its own. There, that's a little bit better. There we go. Okay. Number 1, here is our cute little trinomial. It starts with x squared plus 7x plus 12. Remember, this is b, and that is C. So we are looking for two numbers that add up to B, and those same two numbers have to multiply to get C. So what is B? B is a positive 7, and C is a positive 12. Okay? So, if I were you, I would start with the factors of 12. What multiplies to get 12? Well, 1 and 12. But if you put a 1 and a 12 here, that doesn't add to 7. So it's not 1. How about 2 and 6? 2 and 6. Is 2 plus 6 7? No, not 2 and 6. How about 3 and 4? Is 3 plus 4 7? Yes. Is 3 times 4 12? Yes. So that's the answer. You have just found your factors. A positive 3 and a positive 4 makes a positive 7 when you add. Positive 3 and a positive 4 makes a positive 12 when you multiply. So now you've got your factors. Now here's how you're going to write it. Two sets of parentheses. Oh my gosh, can you believe it? Oh my gosh, Glessner, I didn't ask the first question. I'm a terrible, terrible role model. We should have started by asking the first question. Can you factor anything out of an x squared, a 7x, and a 12? Hey, guess what? The answer is no, you cannot. So, whew, crisis averted. But I'm not setting a very good example. I always want you to ask that first question, can I factor anything out? Because sometimes the answer is going to be yes. It is. Okay, I promise. Okay, it's a no. So, here's what you write in your parentheses. We've got an x in each parenthesis. That's going to give us the x squared if we were to FOIL. Then, these two numbers, the positive 3, the positive 4, that's what goes in your parentheses. That's it. You're done. That's your answer. Right? You want me to prove it to you? Fine, I'll prove it to you. Let's FOIL this thing. Let's FOIL it just to check. Here we go. First, outer, inner, last. Combine those like terms. And doesn't that exactly match the trinomial we started with? It sure does. So this is the correct factoring. Cool. Do you see why I call it the long way? This is called the long way. Who calls it that? Just me. Nobody else calls it that. It's something I made up. Let's do another one. I'm sure you're just like, yes, let's keep going. This is so fun. N squared plus 3n minus 18. Interesting. Okay, first question. Can you factor anything out? Nope. So we have to go the long way. Looking for two numbers that add up to b, and b is positive 3. And those same two numbers have to multiply to get c, which is negative 18. All right. Wow. Negative 18. That means one is positive and one is negative. Okay? And when I add those numbers, one is positive, one is negative, my answer is positive. So that means of my two numbers, one is positive, one is negative, but when I add them, I get a positive answer. That means my bigger number is the positive number. Okay, that'll make more sense in a minute. What multiplies to get 18? Will 1 and 18? Nope, never is that going to ever sum up to a positive 3, even if one of them is negative. How about a 3 and a 6? A 3 and a 6. If the 6 is positive and the 3 is negative, okay, that would work. That's it. It's a positive 6 and a negative 3. Because guess what? A positive 6 add a negative 3 has a sum of positive 3, and if you multiply those, you get a product of negative 18. So those are your two pieces. Those are your two factors. Positive 6, negative 3. And guess what would happen if you FOILed that? You're going to get right back where you started. You want to see it? I'll show you. I'm not going to show you on every one, but I'll FOIL this so you can see. N times n n times negative 3, 6 times n, and 6 times negative 3. Like terms. And sure enough, right back with the trinomial we started with. So when they start throwing subtractions or negatives in there, that kind of changes this whole process of finding those two factors, those two numbers, doesn't it? You got to think a little bit harder. Let's do this one. Let's do unlucky 13. First question, can you factor anything out? No. Now pretty soon the answer is going to be yes, so just get ready for that. Nothing can come out, so you just leave it as is, and now you're looking for what adds to a positive 7 but multiplies to a negative 30. Okay, so again, one is positive and one is negative. 1 and 30, that's never going to work to make a 7. What else? 2 and 15, never going to combine to make a 7. 3 and 10, 3 and 10, 3 and 10, 3 and 10. That would work, wouldn't it? If I had a positive 10 and a negative 3, that would make negative 30. And if I added those, that would definitely make a 7. That's it. It's a negative 3 and a positive 10. If you're wondering if it matters which of these comes first, like should I have said 10 and negative 3 or negative 3 and 10, it doesn't matter. These two numbers, you can flip-flop them. It doesn't matter who goes, like which one comes first in your set of parentheses, like this. X, X. Now right now I could put the plus 10 here or I could put the minus 3. It doesn't matter. You can do it either way. But I'm going to tell you right now, if you were to FOIL that, you're going to end right back with that trinomial that we started with. Let's do another one. This one gets interesting. K squared minus 12k minus 64. Can you factor anything out? No. So I need something that adds up to a negative 12 that multiplies to get a negative 64. Again, multiplying and getting a negative, you know one of these is positive and one of these is negative. So you need a positive number and a negative number. And when you add them, you end up with a negative. That means your negative number is going to be the bigger number. All right? So let's consider the factors of 64. Oh boy, there's lots of them. 1 and 64, no. 2 and 32, no. 3 doesn't work. 4 and 16. 4 and 16. That would have a difference of 12. That's it. It's going to be a positive 4 and a negative 16. Because if you multiply those, you're going to get negative 64. And if you combine them and add them, you're going to get a negative 12. So it's a negative 16 and a positive 4. Do you see why this is called the long way? Right? It just takes some thinking. K minus 16 and K plus 4. Okay? Oh, Lord. We're going to do a couple more. I think I need to turn the page, though. Let's do this one. Let's do, technically, you don't care, but I'm on 21. X squared minus 11x plus 24. So now we've got a subtraction here, or a negative 11, but a positive here. Can you factor anything out? No, not yet. So I need something that's going to add up to a negative 11, but when you multiply is a positive 24. What in the world? Can you imagine a scenario where two numbers multiply make a positive, but two numbers added creates a negative? Guess what? They're both negative. A negative times a negative is a positive, and a negative plus a negative makes a larger negative number. All right, factors of 24. 1 and 24, that's not going to ever create a negative 11. 2 and 12, no. 3 and 8? 3 and 8, that's going to make an 11. Yeah, that's what it is. It's a negative 3 and a negative 8. That's it. That's your answer. X minus 3 and X minus 8. Again, doesn't matter. You could have put the 8 there and the 3 there. It doesn't really matter. Okay, let's do 2 more. Yeah, I'm on down to 31 if anybody's counting. Check this out. Wait a minute. Wait a minute. I told you we were only going to be doing the problems where this was a 1, right? Like so. Oh, I guess I fibbed because I've changed my mind. Let's tackle these. Let's try these problems because I have a reason. First question. Can you factor anything out? And now the answer is yes, you can. Can you factor anything out of a 4n squared, a 12n, and an 8? Yeah, you can. You can take a 4 out. You can't take any n's out, but you can take a 4 out. Let's do that. Okay, that's what gets left behind. Are you done? No, because now you have the kind of trinomial that we were just working with. So now you have to see if you can factor that, and you can the long way, like we just did up here. So now we're looking for 2 numbers that add up to 3 that multiply to 2. You're like, what? Trust me, it's possible. What are the factors of 2? Well, it's only 1 and 2. And if you add a 1 and a 2, doesn't that make a 3? Sure does. So this gets broken down into its smaller pieces of n plus 1 and n plus 2. Can't forget to bring that 4 with. So here's a good example where you had to ask yourself the first question, can you factor anything out? The answer was yes, and then that created the kind of trinomial we had been working with, right? So let's do one more like that, just for some practice. Last one, 5x squared minus 15x minus 140. First question, can you factor anything out? Of course you can. You can take something out of a 5, a 15, and a 140. You can take a 5 out, leaving behind x squared, leaving behind a minus 3x, and a minus 28. Now, can you factor this? Yes, you can. The long way. What's going to add up to a negative 3, but multiply to a negative 28? Well, here we go again. One's positive and one's negative. And when we add them, we end up with a negative. So we know our negative number is going to be the bigger of the 2. So think of the factors of 28. Well, 1 and 28 is not going to work. 2 and 14, that's not going to ever make a negative 3. 3 does not work. 4 and a 7, oh, disco. And we want it to be like that. We want the negative to be the bigger number because when we add them, we end up with a negative answer. So it's a negative 7 and a positive 4. So the 5 comes along, and we break this guy down into an x minus 7 and an x plus 4. You are killing it, kid. This is awesome algebra. I was so fearful about trying to teach you guys how to factor quadratics and polynomials and all this stuff way back when I heard we were going to be doing remote learning, this is the very first thing I thought of is, oh my gosh, how in the world am I going to explain all of this remotely? But I think the answer to that question is this. We're going to take our time. We're going to spend as much time on any one of these lessons as need be. And if you're having trouble, you know you're going to have to reach out to me. And I will do my best to help you from my kitchen. Okay? So stay well. Thanks for watching. Get away from your computer. Get outside. Get some fresh air. And just know that I miss you guys and I appreciate everything you're doing to stay engaged. All right? Okay, guys. Be well. Bye-bye.